Hello everybody, and welcome back to another Big Ideas lesson. Today we're going to talk about 8.5, but I think we require a little bit of reflection first. Let's go back all the way to 8.1 through 8.4. From 8.1 to 8.3, we learned about standard form. The big appeal of standard form is it's nice to have all your terms just sort of written out. There's no more math you need to do. It is as written out as you can possibly make it. The problem is, while it's easy to find the y-intercept, it's easy to find your stretch and shrink, it was not very easy to find your vertex when you had a b value. So it has its uses, but not really the best. Vertex form fixed one of those issues. It's a lot easier to find your vertex here. Your vertex is going to be your h value, comma, your k value. That's why it's called vertex form. But you still need to be able to graph some points in order to graph it. Intercept form is nice because by using intercept form, you can find your vertex and your x-intercepts very, very easily. Before we talk about intercept form, I want us to go back to Unit 7 and talk about when we were able to solve problems like this. Let's say I had the following problem. X squared plus 6x plus 5. And I wanted to figure out the zeros of this problem. So I would set this equal to 0. The problem is we cannot find the zeros of something that is in standard form. We have to factor it first. So how do we factor something like this? This is where we have to review our factoring notes. The first thing we ask is it a binomial, trinomial, or does it have 4 terms, making it a quadrinomial? Well, there's only 3 terms. It's a trinomial. So we wouldn't factor this using the difference of squares. We wouldn't factor this using the grouping method. The next question we have to ask is there an a value? Well, no, there's nothing in front of our x squared. So we are clear to say, nope, there's no a value. And when there's no a value, there's only one way we factor this. We used simple factoring. And the simple factoring method just involved us setting up a combinator and solving. And when we solved it, our 2 answers were just our 2 factors. Let me show you what I mean. We would set it up where we would have our 5 up on top, because that's what we're multiplying to make, and our 6 down below. Now this is going to be a little bit tricky because you may be tempted to say 2 and 3, but 2 times 3 is not 5. 2 times 3 is 6. What multiplies to make 5 and adds to make 6? There's only one answer. 5 times 1 makes 5. 5 plus 1 makes 6. So we took these answers and we wrote them out as our 2 factors. One of our factors was x plus 5. The other factor, x plus 1. And we were done. But hang on a second. Don't these 2 forms look familiar? This looks a lot like our standard form. Instead of the y, we have a 0, but we have our x squared term, and our x term, and then our 1's term. It turns out this second version is going to be close to what we write down for our intercept form. Intercept form is as follows. Y equals our a value, once again, times x minus p times x minus q. Notice how much it matches up with the others. All 3 of these forms have our a value controlling our stretch, shrink, and flip. The difference here is pretty huge, though. We have factored our terms into x minus 1 factor and x minus the other factor. These 2 bits, our p value and q value, are our x-intercepts. In other words, where our graph crosses our horizontal axis. So, in this case, our x-intercepts will be P and Q. Let's take a look back at our equation here. If we had our equation all the way up here as y equals x plus 5 times x plus 1, what are our P value and Q value? Be very careful. Just like with vertex form, we want x minus whatever our P value is. Here's a hint for how you can figure it out. We've mentioned before that the roots of a polynomial are the same as the zeros of a polynomial, which is the same as the x-intercepts of a parabola. So, if we could figure out what x is when y is 0, we will know our intercepts. So let's do that. Let's set y equal to 0 and figure out what x should be. To do that, we set each piece equal to 0. So 0 equals x plus 5, because it's one of our factors, and 0 equals x plus 1. To solve, all we need to do is get x by itself. So let's subtract 5 from both sides, giving us our first x-intercept, negative 5. And we subtract 1 from both sides, giving us our second x-intercept, negative 1. So our x-intercepts, P and Q, are negative 5 and negative 1. And that makes sense, right? If we wanted this to be x minus P, it would make sense for our P value to be negative. That way, when you simplify it, x minus negative 5 turns into x plus 5. And the same applies with our x plus 1. So, when we graph this parabola, we've already known 2 of our points. We know that our x-intercepts are going to be negative 5 and negative 1. So let's put a dot at x equals negative 1, and let's put a dot at x equals negative 5. Very nice. We also know that we don't have an a value here. Our a value would be imaginary 1. So our parabola is going to be up like a cup. The problem is we don't know where our vertex is. I mean, shoot, it could be right here. It could be all the way down here at the bottom. Let's talk about how to find our vertex. First off, where do you think the axis of symmetry is? Where do you think our parabola is going to be cut in half? Well, this is interesting, because we know if our parabola is going to be cut in half, it should look the same on both sides, right? It would make sense to be halfway in between these 2 points. We also happen to know our vertex is going to be on this line somewhere. So this is a great start. Where is this line? Well, let's figure it out. Anytime you're trying to find the halfway point between 2 numbers, you're really trying to find the average. Like, let me ask you, what's halfway between, let's do 24 and 60, let's just do 60. If you wanted to find what's halfway there, you could just work your way towards the middle bit by bit, but there's actually an easier way of doing this. It involves adding your 2 x's together and dividing by 2. That's how we find the average. So to find what's halfway between 24 and 60, for instance, we would do 24 plus 60 divided by 2. 24 plus 60 is 84. We have that over 2. And 84 divided by 2 is 42. 42 is halfway between 24 and 60. It's 18 away from both of them. Let's do the same with our x-intercepts. If we know our x-intercepts are x equals negative 5 and x equals negative 1, what's halfway between them? Well, it'll be our axis of symmetry. halfway between -5 and -1, we can figure out by using our formula. The formula that we use is going to be P plus Q over 2. Our P value is -5. Our Q value is -1 divided by 2. Well, -5 plus -1 is -6, and -6 divided by 2 is -3. So our axis of symmetry is at x equals -3, and that looks about right from what we did before. What do we also know is at -3 then? We know the x value of our vertex will be -3, since the x value of your vertex is at your axis of symmetry. Okay, can we use this -3 somehow to find the y value of our vertex? It turns out the answer is a resounding absolutely. As a reminder, our equation is y equals x plus 5 times x plus 1. Well, if we know our x is -3, let's plug in -3 and see what we get. So we're going to change out all of our x's for -3. So this becomes -3 plus 5. And this is going to become -3 plus 1. Well, what is -3 plus 5? That's +2. And -3 plus 1 is -2. So our y value is whatever 2 times -2 is. 2 times -2 is -4. So the y value of our vertex is -4. Which means we can now make our graph. Or there's our vertex, there's our x-intercepts. Our graph, our parabola, is going to look like this. And we're done. This is why vertex form is so nice. It's because you can immediately graph your parabola. So, in short, your x-intercepts are your zeros. Set your equation equal to 0 and solve to find your p and q. Sorry, your x-intercept, I should say. After that, halfway between them is your axis of symmetry. That's where your vertex is. So here's what I want you to do. We've already sort of done problem number 3, in a way. I want you to try out problems number 4 and problem number 6 as well. Pause the video here. And what I want you to do, again, is I want you to solve for the x-intercepts, graph them, find your axis of symmetry halfway between them, and use that to find your vertex. Pause the video here, and let's take a look once we come back. Hopefully you had a chance to try it out at least. So here's the deal. Your x-intercepts are just going to be your p value and your q value. Well, our p here is 3, because that's what x has to be to make this 0. Our q here is 1, because 1 minus 1 will give us 0. So our x-intercepts are +3 and +1. If we're going to plot this on our graph, it means it's going to look something like this. It's going to be to the right 3 and to the right 1. So I'm going to make our graph like so, and I'm going to put down our two intercepts, x equals 1 and x equals 3. There we go. Again, our x-intercepts are 3, 0, and 1, 0. And we know our axis of symmetry is going to be halfway between them. What's halfway between 1 and 3? We could use our formula to figure this out. To do so, we add 1 plus 3 and then divide by 2. That'll give us 2 as our axis of symmetry. Which means we also know part of our vertex. We know our vertex is going to have that x value as its x value. So our vertex is going to be at 2 comma something. But how do we find that something? We go back to our equation and we plug in 2 for x. So y equals -4 times 2 minus 3 times 2 minus 1. Well, let's take a look at what this gives us. We'll still have our -4 in front. 2 minus 3 is -1, and 2 minus 1 is just 1. So what is -4 times -1 times 1? It's 4. So our vertex is at 2 comma 4, meaning it's all the way up here. Our parabola then is going to look like so. It's going to be a very stretched out vertically parabola, and it's going to be flipped. Number 6 is a little bit trickier because it's not in intercept form. We need to put it in intercept form. Well, how do we do that? We have to factor. So we ask ourselves, how do we factor something that doesn't have an a value? We can use simple factoring. So we set up our combinator, and let's figure out what multiplies to make -15 and adds to make 2. Well, that's going to be 5 times -3 will give us -15. 5 plus -3 gives us 2. So really, this equation is going to become f of x equals x plus 5 times x minus 3. To find our p and q values, in other words, our x-intercepts, we're really just trying to find the zeros. So what should x be here to make this whole term 0? What plus 5 is 0? Well, obviously, -5. -5 plus 5 will give you 0. So one of our x-intercepts is -5, 0. Our p-value is -5. What's our q value? What minus 3 will give you 0? Well, 3 minus 3 gives you 0. So our q value is 3, and our other x-intercept is at 3, 0. We'll graph these in a bit, but first I want to ask, what should our axis of symmetry be? What is halfway between these? Well, we can take our p-value of -5 plus our q value of 3, add them up and divide them by 2. And you'll see halfway between -5 and 3 is -1. You know what else is -1? The x value of our vertex. -1, because it's going to match our axis of symmetry. So now we just have to ask, what do we do with this -1? Why, we plug it back into our intercept form. Everywhere we see an x, we're replacing it with -1. So f of -1, in other words, the function at x equals -1, is equal to -1 plus 5 times -1 minus 3. Well, -1 plus 5 is just going to give us 4. And, of course, -1 minus 3, that's going to give us -4. -4. 4 times -4 is -16. So our vertex is going to be at -1, -16. Well, how do we graph something this crazy? There's a couple of ways of doing it. You could just have an axis right down the middle and just assume that we're counting down to the very low parts. But that wouldn't help us because we wouldn't be able to find our intercepts. Instead, here's what I recommend. I recommend making your axes like relatively normal. From here, I recommend you scale your y-axis to a different scale. Instead of going up by 1s every time, maybe we go up by 4s every time. 4, 8, 12, 16, 20. And down here, it would be going down by 4 every time. -4, -8, -12, -16, -20. Of course, we also want to clarify on these axes that we're doing just fine. We're doing just our normal scaling. 1, 2, 3, and over here we would have our negatives. -1, -2, -3, so on and so forth. So all we need to do now is plot our intercepts and our vertex. Our x-intercepts were -5, which is all the way right here, and 3, which is all the way over here. Our axis of symmetry, right down the middle, is -1, so it should be right here. And our vertex was at -1, right there, down to -16. So our graph looks something like this. Granted, it's very squished because of our scaling. Our scaling changes the shape, but it's still going to be our parabola. With that said, everybody, that is it for lesson 8.5, and that's the end of Unit 8. So give yourselves a pat on the back, and have a fantastic rest of your day.